So let's find a hypothesis test for a mean. We're going to test the claim that the average heart rate of ICU patients is at most 95 beats per minute at the 1% significant level. We're going to use StatKey data to run a randomization test for a mean. So we'll have to make sure we have the right data set and the right null hypothesis, generate at least 6,000 other samples based on the sample of 200 people that had an average heart rate of 98.925 with a standard deviation of 26.83. Those numbers are there to make sure we have the right data. All right, before we can go to StatKey and run the test, we have to be clear about what our population parameter is and what our hypotheses are. So I'm going to take population to be all possible ICU patients, and the parameter is going to be average heart rate in beats per minute. So first I'm going to define my parameter mu, and it is the average heart rate of ICU patients. In beats per minute. Do we know what the average heart rate of all ICU patients is? And the answer is no, we don't, but we have a claim here that says it should be at most 95 beats per minute. All right, what does at most mean? Well, at most, that's the most it can be. So that means mu is less than or equal to 95. Since there's an equal, this has to be a null hypothesis, not an alternative. Okay, it's good to know. My null hypothesis is mu is less than or equal to 95. And my alternative then, well, what's the alternative to less than or equal to? I guess it's greater than, right? Mu would be greater than 95. And we can't go do anything in StatKey till we know the alternative, because the alternative tells us what test to run. In this case, we're going to run a right-tailed hypothesis test. And we'll get a p-value and compare that p-value to alpha equals 0.01. All right, let's go do it. All right, so here I am at StatKey. I'm doing a hypothesis test here, and I want it for a single mean. So we have to choose the right option here. I don't want body temperature. I would like, let's blow this up a little bit. I would like ICU admissions heart rate. And the claim was that this should be a sample of 200 with a mean of 98.925 and a standard deviation of 26.83. So check, I've got the right data set in. And ooh, I don't have the right null hypothesis. I want a mean of 95, not 72. All right, so before we can start running new samples, we need to make sure we have the right original sample and the right hypothesis value. Now I can generate thousands of samples. So a reminder, what's going on here? The computer program is taking a look at the original sample, treating it like a deck of cards and reshuffling a new set of 200 people each time. And lots of variation can happen there. Like if you check out this bottom right corner randomization sample, if I point to one of these dots over here, I'm pointing to a sample of 200 with a mean of 98.345. Over here on the left, I'm pointing to a sample of 200 people with a mean of 92.525. So the computer is simulating based on the original sample, other possible variation in ICU patients, assuming this is a good representative random sample. All right, what am I at? 5,000, let's go to 7,000. Boom, there we go. Then I'm doing a right tail test. And I need to then replace this heart rate down here, average heart rate, the one from my sample. So I want to see where does my sample fall compared to the 95. My sample had an average of 98.925. And then StatKey recalculates and says about 1.8% of other similar samples will have a mean of at least 98.925. And that is what we call a p-value for a right tail test in this case. So I'm getting a p-value of 0.018 based on my sample average of 98.925. So let's go make a sketch of this and figure out what it means. There we go. So I'm going to draw my best bell-shaped curve down here. There it is. And right down the middle, is the null hypothesis value. Mu is equal to 95. And my sample statistic ended up being around here-ish. So that was the 98.925. So that would be called X bar, right? And then the percent of other possible samples that have a mean greater than 98.925, when we were expecting the mean to be 95, StatKey estimated that at about 1.8%. And if I were to run this whole test again, that's going to vary just a little bit. So let's just double check. If I reset this, again, I still have the right sample data to start with. You gotta always make sure you have the right sample, make sure you have the right null hypothesis. Then you can generate thousands of new samples, and you should get at least 6,000. I go for 7,000 again. And it's reshuffling the deck thousands and thousands of times. What's my sample size? It's still 200, but I just have 7,000 other samples, each of size 200. And I'm going to do a right tail test again. And I'm going to replace the value down here with my 98.925 from the sample. StatKey says, hey, look at that, same. Now the graph looks a little bit different. It's a little more right skewed than my other one was, but it's still that same bell-shaped distribution. I got the same p-value. All right, so there's the problem I'm working on and homework. Here's my notes on it. So this right here is my p-value for the right tail test. And then what we always do next is we compare the p-value to alpha. So my p-value is 0.018. Alpha is 0.01. My p-value is bigger. Your test is positive, rejecting the null hypothesis. If your p-value is smaller than alpha, mine is not. So what does that mean? It means 98.925 is close enough to say, yeah, it's still around 95. It's just a little bit higher, not much higher. So in this case, my decision would, because my p-value is large, is to fail to reject the null hypothesis. What does that mean? Fail to reject it. Well, that means my data supports the null. That an average of 98.925 out of 200 people isn't that much different than an average of 95. So in this case, the data supports the null, not the alternative. At the 1% significance level, right? If it was a 5% significance level, that'd be a whole nother story. So fail to reject null hypothesis. So I have a decision, I have a p-value. Conclusion is where we write it up like a press release. How would I state this, in a hospital news letter about ICU patients' heart rates? Well, to do that, I need to know what my variable is. So again, that's the average heart rate. And can I say that the average heart rate is 98.925? No, that was just this sample, right? All I can go off of is that mine happened to be greater, but not a lot greater. And so I'm going to state this in a kind of non-technical way. Let's see. So one thing I could say is we do not have sufficient evidence to reject the null hypothesis. But I'm going to state that without saying null hypothesis. So we do not have sufficient evidence. That would be our sample data. Sufficient evidence to reject the claim, and then we state the claim that the average heart rate of ICU patients, so exactly how we noted it from the problem description, average is at most 95 beats per minute. So semi-technical way of stating it. I don't want to use the word hypothesis, null hypothesis. Definitely don't want to use the word null, right? I wanted my mom to kind of get what I'm talking about here. So And I could say based on the sample, we do not have sufficient evidence to reject the claim that the average heart rate of ICU patients is at most 95 beats per minute. So that's the conservative way to state this. I could also state the data supports the claim that the average heart rate of ICU patients is at most 95 beats per minute. And that is called a conclusion. And so this particular homework problem asks me to select the right hypothesis set here. And this is a mean and not a proportion, so don't pick up P. And at most meant less than or equal to. So I'm looking for one that had a mu is less than or equal to. I see it right here. And then alternative HA, H1 greater. That alternative told me to make a right tail test, and I found a p-value of 0.018. And my decision, because that's bigger than the significance level alpha, that means I fail to reject the null hypothesis, and then I have to read each of these and pick the one that suits my my own conclusion. So I'll leave that part up to you. Have a good day. I hope this helped.